And let me actually start recording this. I forgot to record it. So let's imagine we have this coin. So we have this coin. So we'll do a little face right here. We'll do a nose, some eyes, so forth. So say we have this coin and we're trying to find what percentage of the time the coin will land on heads. Right. So we're interested in what percentage of the time the coin will land on heads. So say we're aliens. We have no idea how this coin works. We just know we want to find the percentage of time that this coin will land on heads. So we have no idea. So say we have two people. So we'll have person A right here, put A. We'll have person B right here. So person A tell you it should be anywhere from 0.40 to 0.60. Person B tell you it could be anywhere from 0.20 to 0.80. Who answer are you more confident at? If somebody tell you that it's from 0.4 to 0.60, or somebody could tell you that 0.20 to 0.80. And if you want, you can put it in the chat. Where is the chat? All right, so we have, yeah, and P is for proportion, correct. So we have one person said A, we have one person says B. So the person who said B, why B? You can put it in the chat if you don't want to talk. Like, why do we feel more confident with person B saying that's from 0.20 to 0.80 versus person A who says from 0.40 to 0.60? Crickets. All right. Well, like the reason why you should have said B versus A, because if you look at person B, they gave me a bigger range. If you look at person A, they gave me a smaller range. Cool. So that's where the confidence come from. So when we're talking about confidence interval, pretty much whatever interval have a bigger range, we're gonna be more confident in that because we're more confident that between 0.20 to 0.80 versus that it's from 0.40 to 0.60. You could kind of think about it. For 0.20 to 0.80, you have more options. So if the coin happened to land 30% ahead, and for person B will be correct because he said anywhere from 0.20 to 0.80. But if you look at person A, since person A only told you 0.40 to 0.60, person A will be wrong because 30% is not within that range. So whenever we're referring to confidence, you're usually referring to the interval. So we're looking at the interval and we're seeing like how confident are we in that interval. The bigger the range it is, the more confident we should be in it. The smaller the range, the less confident we're actually going to be in it. All right. All right. Everybody kind of get why person B, we should be more confident in person B versus person A?
Yes.
All right. So there's something called a confidence level. So usually confidence level, we usually pick like confidence level, like 90% confidence level, 95% confidence level, 99% confidence level. Those are usually like the main confidence level we want because you really don't want a lower confidence level because you want to be confident in your answer. So usually when we're doing a confidence level, it's referring to the method that we're using. So let's go back to this coin. All right. So say one person flipped this coin. So we'll say this is our first sample. And they flip the coin and they get heads, tail, heads, heads, tail, tail, tail. 1, 2, 3, 4, 5, 6, 7, 8, 9. Cool. So say we do that. So we flipped in 10 times. Of the 10 times, how many times did it land on heads? Yeah, 4. So we'll put 4 out of 10. So does that automatically mean that the coin, that the time that I land on heads is automatically 40%?
No.
No, because that's only one sample. So then what I could do another sample. I could do tails, heads, heads, tail, heads, heads, tail, tail. 1, 2, 3, 4, 5, 6, 7, 8. So we could get tails, heads, heads, tail, heads, heads, tail, 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 heads. In this case scenario, how many times did I get heads?
5.
5. So we'll say 5 out of 10, which is 50%. So when we're talking about confidence level, you're usually doing this multiple times. So we're saying we're doing multiple selections. I can't just trust one sample. Usually what you want to do, you want to have multiple of these samples. And the confidence level is telling you how confident we are in each one of these samples. So once I get this 40%, we create a confidence interval for it. So we'll say this is 30% to 50%. This is 40% to 60%. And right now, don't really focus on how to get the confidence interval. We'll actually go over that on Wednesday. So when we're creating each one of these confidence interval, this is corresponding to the confidence level because the confidence level gonna tell me how confident we should be in all of my confidence interval. So you kind of want to know the difference between confidence level and confidence interval. Confidence interval mean the interval that we actually get from our data set. Confidence level represent on how confident we are in this method. So it's telling us if I do 100 sample, we should only be confident in the 90% of the 90% of the sample, 95% of the sample, or 99% of the sample. So right now, what we're gonna go ahead and do, we're gonna go ahead and do a simulation. So hopefully with the simulation kind of help you out. So let me share this web page. I'll actually do the screen. We'll do it work right there. So let me get. Where's my confidence interval? There you go. All right. Everybody see how it says Rossman/Chan applet collection? All right, cool. All right. So what we're gonna go ahead and do right now, we're gonna see how does everything get affected by value. Reset. Okay. So we're still doing the coin problem. So right here, if you look at it, it says 0.5. 0.5 means the probability that the coin should land on heads. The 10 represent the 10 sample size. The 1 interval represent how many intervals do I have. So let's do a sample. And if you look right here, it says 95% confident. So let's do a sample. All right. So if you look at the middle number, or sorry, if you look at the black line in the middle, that's your population proportion. So that's your P. If you look at the green line, this is your confidence interval. So if I actually click on it, it should tell me my confidence interval. So if you look at it saying 0.296 all the way to 0.904. Everybody see the, well, you probably don't see the 0.926, it's pretty small. But everybody see the green confidence interval? And you put yes on the chat if you did. All right. So if you look at it, the reason why we have a green line or why we have a green horizontal line is because 0.50 is between 0.296 and 0.904. Cool. Well, the confidence interval is in green, correct? So if 0.50 wouldn't fall between these two numbers, then it will be red. But the thing is, since it's green, that's telling us that 0.50 fall between these two numbers. So that means that this confidence interval was actually able to tell me the correct parameter. So it was able to tell me my correct parameter should be anywhere from 0.296 to 0.906. Everybody good so far with that green confidence interval? Okay. So up next, we're gonna see how does the confidence level, how would that affect my confidence interval? So say if I go from 95% confidence level, say we go to 50% confidence. So if I go from 50% confident, should it become narrow or wider? So should this green confidence interval, should it become narrow or should it become wider? Cool. All right, so we have one for narrow. Anybody else for narrow or wider? Okay. So we think it could get narrower. So if we kind of look at it, we go from a confidence level 95%, and we're going to a confidence level of 50%. So we're kind of thinking it should get narrower because since we're getting less confident, we only get less confident if our confidence level goes down. So let's actually see what happens. So we'll go recalculate. If you look at what happened to my confidence interval? Did it get wider or did it get narrower? Yeah, so it got narrower. But if you look at it, it still captured the population proportion because it's still in green. If it's in green, that means capture it. I don't know if you're able to see, but it says 0.496 all the way to 0.704. So 0.50 fall between those two numbers. So that why it's green. All right. So let's see what would happen now if I say I want a confidence level of 10%. So if I want a confidence level of 10%, should it get narrower than this or should it get wider? So if I go from 50% to 10%, what would happen to my confidence interval? All right, so we have one for narrow. Anybody else for narrow? All right, so we got two for narrow. So let's go ahead and see this. All right. So if you look at this, it did get narrow, but now if you look at it now, it's red. The reason why it's red because it was not able to predict that the two numbers in between didn't capture the 0.50. So that's what we're trying to do with the confidence interval. We're trying to capture the true population proportion. So kind of think about it. I don't know what the population proportion is, but I'm trying to get a confidence interval, and this confidence interval should kind of tell me what that population proportion should be. All right, so that's how confidence level get affected. So let me go ahead and put this 95% again. So let's see what happens if I change the sample size. All right, so let's do sample size. So let's say if I go from a sample size from 10 to 100. So say if I go from a sample size, so if I change my n from 10 to 100, what do you think will happen to this green line? Would it remain this wide? Or do you think it will get wider? Or do you think it will get narrow or smaller? All right, so we have one person saying smaller. Anybody else? All right, cool. Two people think smaller. So let's try this out. So let's do sample size of 100. So we'll say a sample. So what happened to my confidence interval? Did it become wider or did it become smaller?
Smaller.
Yeah, it actually became smaller. And the reason why it became smaller, because if I have a bigger sample size, I'm getting a more precise answer. So when we talk about more precise answer, that means it should get narrower. Because the narrower it is, the more precise the answer should be. The wider it is, the less precise answer it should be. So if I keep on getting a bigger and bigger sample size, this should become smaller and smaller. So say if I go sample size of 100 to 1,000, what do you think will happen to this interval? Would it become wider or would it become now smaller? Well, let's go ahead and try it out. If you look at it, it got smaller. So anytime we want a more precise answer, if we want a more precise answer, what you want to do, you want to take a bigger sample size. Because if you have a bigger sample size, it should make sense that you should have a more accurate answer, because the bigger your sample size is, the more accurate it should be. Because kind of think about it, if I only take a sample size of 1 versus if I take a sample size of 100, I'm more confident in the sample size of 100 because it's going to be more precise versus the sample size of 1 is going to be less precise. All right. Everybody kind of understand what happened to sample size. So as your sample size goes up, your confidence interval gets smaller. As your confidence level becomes smaller, your confidence interval actually become smaller too. Okay. Any question in regard to that so far?
No.
All right. So up now we're getting to the last thing about confidence interval. So for confidence interval, if you kind of remember from my example about flipping a coin, I took a sample size of 10 flips, but then I did another sample size of 10 flips. Because I can't just trust that one sample. Usually if you're doing a confidence interval, you want to do this multiple times. Because the more time you get a sample, the more accurate it should be. So usually what they do for the confidence interval, they'll take like a sample of 30 people and create a confidence interval. And then they'll get a new sample of 30 people and create a confidence interval with that new sample. And that way you should have a more accurate data set. So when we're referring to the confidence level is saying if I repeat this method of getting a confidence interval many, many times, 95% of the time I should be correct. The other 5% of the time I'm going to be incorrect. So let's go ahead and demonstrate that with this problem. So what I'm going to do, I'm going to update the interval from 1 interval, and we're going to do 100 interval. So if I have, let's say, a 90% confidence level, how many intervals should I expect to be green?
Nine.
Well, why 9?
I don't know, because it's 90.
Wouldn't, if it's 100 interval, wouldn't it be 90 interval?
Oh.
Yeah, so if we're doing this 100 times, 90% of these intervals should be green. The other 10% should be red. But just remember, what percentage is not always a guarantee you're always going to get that. You might get like 91 are red, or sorry, 91 are green, and 9 of them are red, and so forth. So let's go ahead and do this. All right. So for this one, how many red interval do I have?
8.
Yeah, I have 8. So that means we have 92 greens and 8 red interval. So that's what the confidence level is also telling me. It's telling me if I repeat this method many, many times, how many of those methods or how many of those times would it be correct and how many times would it be incorrect? So say I change this to a 10% confidence level. How many green ones should we expect now?
90. Oh,
So,
wait. 1, 2, 3.
so how many green should I expect now?
91.
So I should. So if I, all right, good. So if you look at it, since it's 10%, that means I should expect 10 green and then like 90 red. So let's go ahead and do the sample. Very good. So if you look at it, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Cool. All right. So if you look at it, you have roughly 24. Well, if you look at it, I'm counting out the green one, Melinda. So I'm counting, or let me see. Recalculate. So we count all of these green one right here. So we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. So for this one, you get 23 that were correct. The other were incorrect. So that's how you want to look at confidence level. Confidence level, you're telling you if I repeat this activity or if I repeat this method many, many times, this is how many times we should expect it to be correct. This is how many times we should expect it to be incorrect. So the confidence level telling us 10% of the time it should be correct. The other 90% of the time it should be incorrect. Any question in regard to the confidence level?
Okay, wait. I'm a little confused because didn't you say there should be 10 green lines?
Yeah. So there should be 10 green lines, but like anything, like sometimes not going to be exactly 10 lines. And this one we got 23. Like, let's see if we do another sample. That's funny. Yeah. For some reason, for 10%, really doesn't work out that well. Let's see if I do 40%, 50%.
It seems like the intervals get a little bit bigger than the percentage, right?
Yeah. Here, let me see if I reset the 10%. I think it also has to do with the sample size I'm choosing. So here, let's see the. Yeah, there you go. Yeah, because the sample size that I have was too small. So yeah, so if you look at it, the confidence level, you're telling us how many of these should we expect to be red, and how many of them should we expect to be green. So if you actually look in the side, it says we have 10 green out of 100, so that's 10%. So if we do that again, if you look at it now, we get 19 out of 100. So if we do that again, you get 13 out of 100. If we do that again, you get 14 out of 100. So it pretty much gave me something close to 10%. Any question in regard to this simulation? All right. So pretty much the whole point of this is just to kind of get you understanding what the confidence interval is. Interval, the confidence interval is the interval that we're picking or we're creating. And we're hoping that between this interval, the actual population proportion is in there. So I could have a confidence interval that I could tell you it between 0.40 to 0.60. And we're hoping that in between the 0.40 and 0.60, our true population proportion is in there. So if our true population proportion is 0.50, then 0.40 to 0.60 would capture it. But say it's a true population proportion at 0.70, now my confidence interval doesn't capture it. So the whole point of these confidence interval is to capture the true population proportion. All right, so hopefully you got that from this simulation. Any question in regard to this simulation? Cool. All right, so for next Wednesday, if you can, either download these files or oops. What I want you to do, either download the file or if you can, print them out because we are going to need them for next Wednesday. So the two files, if you go to home, if you go to table, these are the two tables you're going to need for Wednesday. So if you can, you'd have it ready on your laptop. So you're gonna need a T-table. We might get to the chi-square table, but most likely we won't do chi-square table until next Monday. So for Wednesday, for sure have the T-table, and we might get to the chi-square table on what you call it on Wednesday, but most likely we'll get to this on Monday. Any question on these two tables? All right, cool. All right, so that's it for today's lecture. So pretty much we're all done for today. So if you still haven't taken the test, do take the test as soon as possible. If you still haven't taken the test, well, if you already took the test, well, don't worry about it. Enjoy your day, and I'll see you either tomorrow or Wednesday. So if you do have questions about the test, just show up on tomorrow during the lab, and that way I'll be able to answer any question. And tomorrow during the lab, like you should have the answer for the question. The only answer you won't have is for the Banks theorem, because that one pretty much you have to upload it, so I'm not gonna give you the answer. But for any other question, it should give you the answer for it. Yeah, you'll be able to do test correction after. Any question in regard to anything?
How many more tests are we gonna have after the second one?
One more,
Oh, okay. And then a final or
and then the final.
oh, okay.
All right, any other questions? All right, guys, so that's it for today's meeting. I'm gonna close down the lecture. So just remember, if you haven't taken the test, do take the test as soon as possible. If you already took the test, well, enjoy your day. Bye-bye.